Okay, this next group of problems, they do a somewhat creative thing, and they go ahead and they tell us a point, and they also tell us the derivative, or essentially the slope at that point. And there's kind of a reason here that they're not telling us the function, because they want us to do this based on our understanding of what a derivative is and not be able to calculate it exactly and kind of skip the middleman there. And so what they ask for is we're going to use this information to approximate a point nearby. So it looks like here they're going a point that's a little bit to the right. They could go a little bit to the left, right? They could go negative 5.05 or negative 5.01. They just happen to pick negative 4.95. So a point really close by. And also notice they say approximate. And here's why. If we have a function, right, we don't know what it looks like. We just know that we have a point negative 5.8 out here. And then we know the slope at that point is negative 6. So a pretty steep downward slope. Like if we had a tangent line there, the slope would be, the slope would be negative 6. So the actual function could be doing anything. Maybe I'll use a highlighter to kind of point out, like it could be, you know, like a parabola kind of thing going like that. It could be sort of a straight line at that point. There could be kind of a curve down and then it could go like this. We don't know what the actual function is doing, but we know that at that point, that's how steep it is. That will be enough information to get us an approximation of a point nearby. Because notice, if the slope is actually like down 6 over 1, right? That's what it means to be a slope of negative 6. Maybe we'll even write that to remind ourselves. So down 6 over 1 is the slope there. Then if I go down just a little bit, or to the right just a little bit, instead of going over 1, I go over 0.05 units, right? From negative 5 over to negative 4.95, like really, really close by. And maybe let's say like the function is this squiggly one. Maybe the point's here and not quite here, but see how it's so close to it as long as you stay kind of in the neighborhood of that. If you go too far away, right, like any function, you have like a function and then you have your tangent line, you know, around here, you get a pretty good approximation. The points aren't too far apart. If you get a point way down the road, that's pretty far off of what's going on with the actual function. So that's why they say approximate, and it's also, let me erase here, it's also why they keep the point nearby. Okay, so then the slope actually gives us everything we need for this. If we go over 1, we would go down 6. So picture if we were to go over 2, we would go down 12, right? The slope is just a ratio of the up and down. It's like how steep your function is, how steep your roof is. And so here, if we want to go over, right, from negative 5 to negative 4.95 is technically over plus 0.05 units. If you're unsure about that, right, just like subtract them, right? You're like, what's the difference between those 2 points? So negative 5 minus a negative 4.95. Those 2 points are 0.05 units apart from each other. Or if you're picturing them on a graph, which is why the picture kind of is always helpful, it's 0.05 in the positive direction, right? You're getting closer to 0. It's to the right of this. All right, so if we go over 0.05 instead of 1 whole unit, then our slope, we should go down, right? It's negative 6 for every 1. So we should go down negative 6 times that amount. So negative 0.3. And another thing you can check, like if these ratios are supposed to be equal, see how negative 12 over 2, like 2 steps over, 12 steps down is negative 6 over 1. You can check, like, is negative 0.3 divided by 0.05. If I take just a partial step over, then I take a partial negative 0.3 step down. See how those are all equal to negative 6 over 1, right? You're not changing your slope. Okay, so then picture if we're taking this in terms of points. Our point used to be at negative 5, 8, and so we're going over 0.05 units. I'll draw us a little, I'll draw it over here just so we can. So we're going over 0.05. We just figured out that means we go down 0.3. See how the point used to be at 8? So if you're at negative 5, 8, and you go over 0.05, in fact, let me erase so I can write it right under it like a little table. I can erase the slope. We're not going to forget it's negative 6, right? So we're going plus 0.05 on the x, which means we're going minus 0.3 on the y. So that gives us a new point of negative 4.95, a little bit to the right and a little bit down of where we were before, which should be like 7.7. And they'll take anything, they say around 2 decimal places, so depending how you go about it, they should take anything in the neighborhood, but that one was pretty exact. And then here's why this is still an approximation. Maybe the actual function doesn't hit that point exactly, but it's going to come pretty close to it because we didn't leave the neighborhood of that original point where we knew the slope. So they're just saying, hey, if you know that 1 step over is 6 steps down, you could take any amount of steps now. You could take 5 steps over, probably not as accurate. You could take 0.1 of a step over, and then you'd take 0.1 times 6 steps down. The slope is a ratio of how far up and down to left and right you go. And so that's the same all the time. That's also why they didn't give you the function, so you can't do it yourself. You have to use the idea of slope and derivative together. So I like that one. It's kind of a sneaky question in its simplicity, the way they put it.